Fun, I like it. So now what we're going to do is we're going to see what happens when we add or subtract a constant behind x squared, all right? So in our graphing calculator, step number 5, we're still going to keep that parent function of x squared as our y1. But step number 2, let's add plus 4 behind it and see what happens. So I'm going to go to my y equals, and I'm going to clear out all that stuff other than my y1, okay? So go to your y equals and clear out all that other stuff other than y1. And you guys are going to quickly see what happens, all right? So in our y2, we're going to graph x squared plus 4 behind it and hit graph. So the first graph it always does is y1, so it graphs our parent function. But then what happens when we put plus 4? What did it do to our graph? Bumps it up, right? If you count, it's kind of hard, but if you count, you can count how many units it went up. 1, 2, 3, 4 units, okay? So adding plus 4, what does the parabola change? It shifts up 4 units, right? So is our vertex different now? Yes, we're not sitting right there at the origin anymore. Did we move left or right any?
No.
No. So what is our x value still? 0. But did we move up or down? Yes, we moved up 4. So what's our y value now?
0, 4.
You got it. So by adding that plus 4 on the end, it's going to shift the y value. All right? So can you guess what a plus 9 is going to do?
It's going to be 0, 9.
It's going to be 0, 9. We don't even need to graph it if you don't want to. It's going to just shift our whole parabola up 9 units. So this shifts up 9 units now.
So then when a be 0, negative 4?
You got it. Okay. So adding this constant on the back is going to shift you vertically, right? So this is going to be up to 0, 9. And then I'll graph this one just so you can see it real quick. I'm going to go ahead and put x squared minus 4. But you can guess kind of what's going to happen. Oops. When you put the minus, it just shifts it down, okay? So if you put a plus, it's going to shift it up. If you put a negative, it's going to shift down that many units. And so like Sadie said, we know our vertex is going to be a negative 4 now. All right, so it says this k is subtracted from the parent function. I don't like how it's worded. Just basically a plus or minus k. Okay, that's just trying to show you the generic. So x squared with a plus or minus k shifts your graph up or down. Okay, so that's rule number 2 that they're trying to state here that we just discovered. Okay, so x plus or minus a constant in the back, we're calling it k, is going to either move it up or down k units, depending on whether your k is positive or negative. Okay, and notice the rule. Look what happens to our vertex now. It's going to go to that 0k, whatever we're adding or subtracting on the back. Notice the axis of symmetry, though, guys, is still at 0 because we haven't moved left or right any. We're still going straight down the middle of that parabola. So this is what I wanted to show you guys, is we have this chart, but guess what? We can do this whole graph without using the chart. So let's try it, all right? So where is our vertex usually for a parent function? 0, 0, but what's this plus 2 going to do to our function? Move that vertex to what? Yep, so it's going to be right there. So I figured out where my vertex was without even doing any math, right? So this, like, maybe write a note up to.
But how is it, so then, how can you tell the difference between this one and, like, the ones we just did? Because they don't have 0 at the end.
Right, they all have 0 at the end, so they're not shifted up or down any, right?
Oh, like
the ones we just did were in front of the x squared.
Okay.
So this is if it's added or subtracted on the back, what we just did was a constant in front, okay? So, how do we find the other points? Well, now that we know where our vertex is, are we changing the shape? No, that's still just the x squared, okay? It's not a 2x squared, it's not a 3x squared, okay? So how do we do this? We use our rules. Remember our rule says go over 1 from your vertex, up 1 in either direction. So we found our vertex was 0, 2, and then we just went over 1 in either direction and up 1. And then remember the rule for 2, you go over 2, up how many? 4, okay? So now go back to your vertex. You got to start at your vertex every time. Go over 2, up 4. 1, 2, 3, 4. Go back to your vertex, go over 2, go up 4, 1, 2, 3, 4. So you should have a normal shaped parabola, right? Not stretched skinny or wide, but he's just floating up 2 units, okay? So you always go over 1, up 1 times A, but in this case our A is just 1. So we went over 1, up 1, and then we went back to our vertex and went over 2, up 4 in either direction. And we just graphed our parabola. And we didn't even have to use this at all, right? What's our vertex now? Well, we kind of just discovered. When we were shifting that up 2, our vertex is now going to be 0, 2. What's our axis of symmetry? We haven't moved left or right, so that's still just x equals 0. What's our y-intercept? Notice that has changed. Where do we cross the y-axis? We cross the y-axis at 2. Okay? That's your y-intercept right there. So we shifted that up 2. It's not always your vertex, okay? This so just happens to be. What's our zeros of our function? Guys, do we ever cross the x-axis down here now?
No.
No, so we have none. And how does it open? Up or down? Up, but again, we could tell from the A. Does everybody understand where the points on the graph came from without doing the chart? Okay? Again, remember you're using that rule. You go over 1, up 1 times A, but in this case A was just 1, so we went over 1, up 1. And then you always go over 2, up 4 times whatever the A was. A was just 1, so we just went over 2, up 4. It was your normal parent function shape-wise, but then it just shifted up 2. So, I ask you, go ahead and turn the page. What do you think putting an addition or subtraction inside the square is going to do? Well, instead of going up or down, it's going to start moving left or right, okay? So go ahead and clear out your y equals except for y1. And in y2, guys, in parentheses, do parentheses x plus 2 parentheses squared and hit graph. So it'll graph your first normal guy, and then notice what happens. Where'd your parabola go and move which direction? Yeah, which to me is kind of the opposite. Like if I saw that plus 2, I would have thought I'd be moving to the right too, but it actually kind of moves to the opposite. So kind of keep that in mind. So your vertical shifts up and down are exactly what you think. Plus 4 on the end moves it up 4, minus 4 on the end moves it down 4. But when it's on the inside, it's all these horizontal shifts, and it's kind of the opposite of what you think. So this shifts left 2. So, what's happening to our vertex now is our x value is changing, right? So if we went to the left 2, what is our x value at now? -2. What is our y value still at? 0, because we haven't moved up or down any. Any guesses on what x plus 9 is going to do? It's going to shift you all the way to -9, right? So you're going to shift, so it shifts left 9 units. So guess what your vertex is going to be? -9, 0. Is that okay? Let's go ahead and do the x minus 4 though and see what happens when you do that. So in your y3, do x minus 4 and notice what happens. Notice he gets shifted to the right. So again, it's the opposite of what you think. So x minus something on the inside actually shifts it to the right. Oh, you didn't put the square. Go ahead and put y equals. Like, where did that come from? Okay, so this shifts right 4 units. So we're at +4, 0 now for our vertex. My negative's kind of there. So what is our rule? If we have x plus or minus h on the inside, that's going to shift it left or right. So anything on the, I call it the inside of the square. So this plus or minus is being squared, where the stuff we just did was outside of the square, right? Is x squared plus 4, x squared minus 9. Now this is inside the square. Anything on inside is a horizontal shift. So again, here's the rule. All right, we're going to shift left, right, and notice what happens now, guys. Our axis of symmetry is going to change now. Because we're shifting left or right, it's going to follow that x value of our vertex. All right, so let's see what's happening here. And again, I'm going to try to do it without our chart. What's this -3 on the inside going to do? Shift it which direction? Right, so this shifts right 3. So what does that mean? It means start your pencil point, don't actually make a point, but start your pencil point at 0, 0, where our vertex normally would be, right? But where's our vertex going to be now? 1, 2, 3 over. You agree? Do we have anything in front of our x term? No. So we know it's going to open up, and we know we're just going to go over 1, up 1, over 2, up 4 from our vertex, okay? So just go over 1, up 1, over 1, up 1, and then go over 2, 1, 2 from your vertex, and up 4, 1, 2, 3, 4. And go back to your vertex, over 2, and then up 4, 1, 2, 3, 4. And again, we just have that normal shaped parabola, that parent function, where it hasn't been stretched any, it's just been shifted.
So you go up 4, you don't go up to the number 4, you go up.
Right, up 4 from wherever your vertex is. Yep. So, because we're going to start shifting up, down, left, right, so you just are always going off, your vertex is home base, really, okay? So your vertex is home base. Find where your vertex needs to be, and everything's going to go off of him. All right, so vertex. Where's our vertex now since we shifted to the right 3? 3, 0. So now what's our axis of symmetry going to be? Well, it's going to go right down the middle of our parabola. So it's going to be x equals what? 3. And again, guys, it always falls off of that vertex. Our y-intercept. The way we graph it, it looks like it's not going to have a y-intercept, but it is, guys. If we kept extending this, he's going to cross the y-axis sometime. So let me do the formula with you. How do we find y-intercepts? You have to let x equal 0. Okay? So in our original equation, we have y equals x being 0. Okay? So I'm just taking our original equation and making x 0, because that's what a y-intercept is. What is 0 minus 3? Negative 3. So what do we have to do to it? Square it. So y equals 9. So what is our y-intercept? Well, what value was x? 0. What value did we just calculate y to be? 9. So if we drew this correctly, this would extend upward and eventually cross the y-axis right here at 9. Okay? So you will always have a y-intercept. You'll always have a y-intercept. So how you find it is just plugging 0 in for x in the original function. You won't always have zeros of a function or your x-intercepts. Notice here, guys, we do have an x-intercept. That's just where we're sitting on the x-axis. So that's just 3, 0. And then which way does the graph open up? Or open, I just told you? Up. There's a lot going on there. So this y-intercept part, guys, you'll always do. This x-intercept, not necessarily will you always have it. And I think on the homework in this section, you don't have to worry about either one. I think it's graphing and just telling where the vertex and the axis of symmetry is, okay? And I'll show you that before we're done.
Will it ever be going up by the negatives? It's in the negatives and it's going
Yes.
up?
Yep, you'll see all of that happen. All right, so what happens, I don't know, I'm a geek. You can tell I'm a math teacher because I love this stuff. We're putting it all together now. So this is kind of like your final, here's everything we've starred today all in one spot, okay? So here is the most complicated form of a parabola. We can have an A in front, which will change our shape, skinny or wide, up or down. We can have a plus or minus on the inside, which will shift us left or right. And we can have a plus or minus on the outside, which will shift us up or down. Okay? And once we figure out where that vertex is, we can use these tools, over 1, up 1 times A, over 2, up times 4 times A, okay? So what I do, notice both of these we're going to graph, and there's no spot for our chart. We're going to be able to do all this by hand, and we'll check it with our calculator, okay? So what I do is I say, okay, what does this minus 3 on the inside do that shifts us which direction? The opposite of what you think. It shifts us to the right 3, okay? So we're going to go to the right 3. But then what's this plus 1 on the outside do? It shifts you up 1, okay? So anything on the inside will be left or right, and it's the opposite of what you think. Anything on the outside will shift you up or down, and it'll be exactly what you think. So this will go up 1. Based on that, we know what our vertex is, right? If our vertex was normally 0, 0, and we're going to the right 3, we're going to go over 1, 2, 3, and then we got to go up 1. What's what's our new vertex?
1, 3.
Flip it.
3, 1.
3, 1. And notice that we kind of see it right here how we set it, right? If you're at 0 and you go to the right 3, you're at 3. If you're at 0 and you go up 1, you're at 1. 3, 1. All right? Now let's draw our other point. Do we have an A in front? No. So our A is just 1. So this is going to be your normal parent function where we're just going to go over 1, up 1 from the vertex in either direction. So over 1, up 1 from your vertex in either direction. And then over 2, up 4. 1, 2, and then up 4 from your vertex. 1, 2, 3, 4. Over 2, 1, 2, up 4. 1, 2, 3, 4. Okay? So we have a normal shaped parabola just kind of floating. Alright, what's our axis of symmetry? Well, he follows our vertex, and since our vertex shifted to the right 3, so did our axis of symmetry, so our axis of symmetry is just x equals 3. How do we find our y-intercept? Our y-intercept is by plugging 0 in for x. So it's 0 minus 3 squared plus 1. I'm just using this function and putting 0 in for x. If you put that in your calculator, exactly how you see it, you'll get it. But we already did 0 minus 3. That's negative 3. Negative 3 squared is 9. That's 9 plus 1, 10. So this is 0, 10 is what we get there. Zeros of our function, guys, are we going to cross the x-axis at all? No, because we're floating above it, and we're going up. So this is none. And which direction does our parabola open? Up, because our A was positive. Let's just double check with our calculator that we graphed the right guy. So in our calculator, let's go to our y equals and clear out everything, okay? Alright, so in our y1, you basically type exactly what you see. So you're just going to go over 2, up 4. So 1, 2, 1, 2, 3, 4. So it'll be right there. So what you're going to do, you're going to type this parabola, the equation of the parabola, exactly how you see it. So we're going to do parenthesis x minus 3 parenthesis squared plus 1 and then hit graph. And it should look like your graph, where you're over there kind of floating in la-la land, okay? It's kind of, like, I like doing it by hand because it's kind of hard to count, like, so we're over 1, 2, 3, and then up 1, so you can kind of count where the vertex is, 3, 1. All right, let's do this last one. So this has every single thing going on that can be going on, okay? So on this first one, what does the negative mean? It's going to open which direction? What's the negative mean? It's going to open which direction?
Down.
Down, yep. What's the 1/2 in front? If you remember, the fractions make it wide, okay? So that's going to widen. So we got to remember, instead of going over 1, up 1, we're going to go over 1, up 1/2, over 2, up, 4 times, whatever that. What's the plus 2 on the inside? Which direction is that shifting us? To the left. Remember, it's the opposite of what you want to say. I do the same thing. So this is going to go left 2. And then what's the plus 5 going to do? Up 5. Whew, okay, so we have it all labeled. So I'm first going to do the shift so we can get our vertex in the right spot. And then opening down means we're going to go over 1, down, whatever. And then the widen, we're going to go over 1, down, 1/2 times 1, 1/2 times 4. So let's see where our parabola's vertex is. We're going to go left 2. So normally we're at 0, 0, but we're going to go left 2, 1, 2. And we're going to go up 5. 1, 2, 3, 4, 5. So our vertex is at -2, 5. Are you guys okay with that? -2, 5. All right. So how do we do our other points? Remember this rule up here. Way up here. You're going to go out 1, up 1 times A. Well, we're going to go out 1, down 1/2, because 1/2 times 1 is just 1/2. So we're going to go over 1, down 1/2, over 1, down 1/2. And then, how we're gonna do the second part is we're supposed to go out to, up 4 times A, but if you put 4 times 1/2 in your calculator, half of 4 is just 2. So we're gonna go over 2, down 2. Over 2, down 2. And you got a slightly widened, it's not like the most wide, but you have the slightly widened, parabola going on there. Okay, so he's a little bit fatter than that one up there. All right, axis of symmetry. He's going to follow our x value of our vertex. So since we shifted to the left 2, our axis of symmetry is x equals -2. I can't tell you how important putting the x in there is. When you go to my math lab, they'll say type an equation. If you just put -2 and they'll mark it wrong, they want x equals -2. Where's your y-intercept? If you guys look, our y-intercept's right here. We crossed it at 1, 2, 3. So y-intercept is just 0, 3. Zeros over functions, let's not worry about that, but what we would do is we'd set this equal to 0 and solve, but we don't have to do it in this section. This is kind of prepping us for the next section. And then how does our parabola open? It opens downward.